find the cubes of digits of a given integer number using a while loop. Now, what exactly I mean by cubes of digits? Let's take an example and illustrate this particular operation. Suppose if the number is say entered as 123, what I need to do is I need to find the cubes of the digits, that is 1 cube plus 2 cube plus 3 cube. So 1 cube is 1, 2 cube is 8 and 3 cube is 27. So the result has to be displayed as 36. So for input as 123, I should display the cubes of digits as 36. So how to find the cubes of these digits? The process again takes us to the same logic that we have to extract these digits. The extraction of digits is using mod 10 and by 10. The number has to be continuously divided and modded with 10 till the number get reduces to 0. So I'll say n by 10 and n mod 10 till is while your n is greater than 0. So I'll say r and I'll say n at this place, and here we are supposed to look at a expression which will find the sum of the cubes of the digits. Now let's look at the code at this place. So I have this particular code and some expression is missing in this. Let's add up this particular expression. So I'm supposed to find the sum of the cubes of the digits. It is exactly same as the previous expression itself. So I'll ask the user to enter the number, read the number as n at this place, and then repeat the operation of extraction till your number is greater than 0. So number is greater than 0. So I'll say r equal to n mod 10, n equal to n by 10, and then I'm supposed to find the cubes. So let's write this with an example itself. Assume that the value of n is 123. R is initially garbage, S is given as 0. Now, what I need to do is, I need to extract the digits. The extraction process is same. While n greater than 0, number greater than 0, 123 greater than 0, true. If it is true, then in that case I'll say r equal to n mod 10. So r says 3 and n equal to n by 10 will get us a value as 12 in this case. Now, I need to write an expression in this case such that the value of s should be now stored as the cubes of the digits. So instead of adding the value of r to s, what I need to do is I need to add the cubes of the digits of s. So here I can write s equals to s plus, that is 0 plus r cube. R is 3, 3 cube is 27. So I'll say 27 in this case. So the first operation yielded us a result as 27. So here you don't just add s with r, what you need to do is you need to add the cubes of r. So hence I'll say s equals to s plus r asterisk r asterisk r. So here the cubes of the digits are added to this particular variable s. So 3 cube is 27, that is added with the value of s, and the result is stored back to s. Let's start the second operation in this place. Now when you go back, your n is what? 12. 12 greater than 0? True. True in the sense r equal to n mod 10. So 12 mod 10 is 2. 12 by 10 is 1. So s equal to s plus 27 plus r cube, that is 2 cube, 8. So 27 plus 2 cube is 35. 27 plus 8 is 35. Now again go back, number is what? 1. 1 greater than 0, true. True in the sense 1 mod 10 is 1. 1 by 10 is 0. These are the operations which happen in the third time. So 1 mod 10 is 1. 1 by 10 is 0. 35, that is s, plus r cube, that is 1 cube. So 35 plus 1 cube is 36. We got the result as 36. So when you go back, your n is what? 0. 0 greater than 0? False. False in the sense there will not be any further execution. And now display the value of s, that is sum of cubes of digits equal to percentage d comma s. The sum of cubes of the number 123 is 36 in this case, hence the result gets displayed as 36. So you can use an alternate function instead of r asterisk r, you can use an alternate function as POW r comma 3. So r raised to 3 can be said as r comma 3. For this you are supposed to include a header file called as mat.h. But generally for squares and cubes, avoid using these power function. You can use a simple mathematical function r asterisk r or r asterisk r asterisk r asterisk r. So raised to 4 or raised to n, probably at that time these functions will become more handy. So for our input as 123, the sum of the cubes of the digits is 36. So the logic was still the same as per the previous video. The only concept was here we added the value of s with, in that case we added the value of s with r, and here we are just adding the cubes of r with the value of s. So we conclude with that particular note. The extraction process is still same as the previous concepts. Thank you.